So in our last session, we did talk about some of the definitions or the terms that are used in solar energy. Today I want us to look at the basic solar energy principles, and that is basically how do we harvest solar energy for use or for human use or for use in our various areas. So when we talk about the basic solar energy principles, there are two ways by which the solar can be harvested. That is to say that the solar energy can be harvested mainly in two forms. One of them is what we refer to as heat. That is what we refer to heat or the solar thermal technology. We can use heat, we can harvest it in terms of heat, or the solar thermal technologies. Or the other way is what we can talk about as the electricity. That is now what we call the PV electricity. That is now what we call the solar photovoltaic systems, whereby we convert it to energy. So because our main area of study is going to be the solar PV systems, so for now we are simply going to talk about how can we convert that into the solar energy that comes from the solar radiation that comes in terms of heat. And basically this one reminds us of what we talked about in our earlier discussion as far as the solar radiation is concerned. And we did say that the solar radiation usually come in three, and one of them is so the solar radiation usually come in three or different categories, and one of them is the infrared, and the infrared is what is responsible for the heat that we are talking about. And the other one is the visible radiation, that is the light that we can see, and then the other one is the ultraviolet, which is now what is always very high energy radiation. So when we talk about the solar harvesting in terms of heat, then we are basically talking about infrared radiation. And when you talk about the infrared radiation, then basically what we are talking about is how are we going to get the infrared radiation? How are we going to get the infrared radiation in order to come up with the heat that can be used in maybe in cooking, the heat that can be used maybe to bring about heating of water? That is now the several ways by which this one can be applied. So when you talk about the solar thermal applications, then the radiant energy is always directed. We can always use what we call the reflectors or the concentrators. So these reflectors or the concentrators, they bring the solar radiation, or rather the solar energy, close to, as far as the solar is concerned, it is always spread all over a very large area. And when you talk about the reflectors and the concentrators, then they usually collect the solar as heat, absorbing it on maybe specially treated surfaces, and by using what we refer to as the greenhouse effect. That is what we'll talk about later on, the greenhouse effect, whereby the solar, we may have some a box. Maybe we can talk of a box that is clear. We can talk of some box that is clear, a clear box like that. Then maybe we can talk of that. Then the solar radiation comes there. Then this is made of glass. Inside here is painted black. And this one will allow the solar radiation to come in, but it will now trap what we refer to as the infrared. And that infrared is what will bring about the heat that will eventually raise the temperature of maybe whatever you are cooking or whatever you want to heat in that order, whatever you want to heat. And in that case, that is what is going to bring about the heat that we are talking about. And this is now what we call the greenhouse effect. The other way is by use of the reflectors, or what we refer to as the concentrators, whereby we can use the concentrators, whereby we can concentrate the power from a very spread area into a small area, and we can use it in order to generate heat. So you'll find that many of the off-grid PV users usually prefer to heat water and also to cook using solar thermal technology. So what we are now talking about is the heat. In fact, what we are talking about currently is now what we refer to as the heat solar technologies. And this one can be achieved majorly by one of them is concentrating solar energy. So we can talk about concentrating solar energy. Concentrating solar energy. Concentrating solar energy, that is one way by which we can always use the solar thermal technologies. So when you talk about concentrating solar energy, then this one usually make use of the reflectors in order to overcome the spread out nature of the solar energy. And they also redirect the solar radiation incident over a large area. They redirect it, and this one will be reflecting and therefore focusing it on a small area where it is trapped or harnessed at high temperatures. And when you talk of the concentrators, then the concentrators also make use of the reflective surfaces and the shapes that usually bring about bouncing effect. And this one will bring about the radiation of their surfaces and direct it to a focal point. So by covering a very wide area, then the concentrators, these concentrators are usually useful because they will focus now on a small area, and this particular small area will now be absorbed in terms of heat, and that heat is what we'll eventually use in order to bring about the heating effect, whereby the thermal part of the solar radiation can be harnessed for use. We can also talk about, when we talk about the concentrated solar power, that is what we usually refer to as the CSP, the concentrated solar power. So that is the concentrated solar power stations. When we talk about this, then these ones usually use, they can be used on industrial scale, while thereby collecting and also converting solar heat to energy, and this one can be sold to the grid. And in this case, this one can always be very, very important. We can always use things like parabolic dishes. We can use parabolic dishes. Or we can also talk about the bowl-shaped mirrors in order to focus the radiant energy upon one point, whereby the energy is concentrated and utilized for the purposes of the solar cookers. We can talk of the solar cookers or any other way that is appropriate. So the other way that we can also talk about is what we call the parabolic. We can talk of the parabolic troughs. Under this, we can talk of the parabolic troughs. So the parabolic troughs, they focus radiation along the pipe, and the pipe runs through the center. So we can have the parabolic troughs whereby we have a pipe that runs through the center of that particular trough, and therefore the energy is focused on that particular pipe, and it is used, the heat that is produced there can be used in order to ensure that we harness the heat part of the heat part of the solar radiation. Then we can also talk about the simple reflectors, whereby we have the flat mirrors or the polished aluminum surfaces that are arranged around a device in order to increase the radiation and the incident, the radiation incident upon it. So we can use this. There's like solar cookers and the concentrating type solar electric systems. We commonly use the reflectors, and we can talk about this. Maybe we can look at simple figures that represent this. We can look at the simple figures that represent this. Talk about the parabolic dishes. So this is what the parabolic dish is about. You can see whereby that one concentrates the solar radiation to that. Then we talk about the parabolic trough. The parabolic trough is now what we have here. So here is the pipe where the concentrated is, and from there we have the parabolic trough, and it is concentrated. The other one, we can also talk about the box type cooker, whereby it consists of the reflector mounted on the box type of cooker. And this one is also used in order to increase the temperature, and we can use this one in order to cook. So that is why we can, that is how we can always harness the heat or the heat energy from the solar radiation, or what we refer to as the solar thermal technology. It's all about concentrating the solar energy, and we've said that when we talk about concentrating the solar energy, then the major things that we usually use are the reflectors as well as the parabolic dishes. Another way that by which we can harvest the solar energy is by trapping. So we can talk about trapping solar energy. We can talk about trapping solar energy. Trapping solar energy. Can talk about trapping solar energy. So when you talk about the trapping of solar energy, then the solar energy is always trapped as heat using properties of heat absorption, heat transfer, insulation, and this is what we usually refer and the greenhouse effect. So we use, when you talk about this, then there are several principles that we use. One of them is absorption. So there has to be the aspect of absorption. Then we must also have the aspect of heat transfer. There has to be heat transfer. Then after heat transfer, we can also talk about insulation. We can also talk about insulation. And finally, we can talk about what we refer to as the greenhouse effect. So these are what entails trapping of solar energy. So you will find that the solar radiation is always absorbed in the surfaces as in form of heat, and the amount of the heat radiation absorbed usually depends on the incident area, the incident surface area. And this particular incident surface area, also there has to be the aspect of color. It depends on not only the incident surface area, but also the color and the material of the surface, as well as the angle and the intensity of the incoming radiation. You'll find that in most cases, the solar energy is best absorbed on surfaces that are perpendicular to the incoming solar radiation. You remember that when we talked about the incident angle, we said that the maximum amount that is received is happening when it hits a solar device or the material at 90 degrees. That is when we have the maximum, and that is why when you talk about it depending on the angle, then that is how that one happens. You will also find that the dark colored, you'll find that in most cases, we usually paint them black. So the dark colored or the black non-reflective metal surfaces usually absorb solar radiation. And in this case, when they absorb the solar radiation, they will be, at the end of it all, will have a lot of heat. And this one can be used in the likes of the solar water heaters. We can also talk about the stills, solar water heaters, stills, dryers, and cookers in order to make use of, all this usually make use of a black painted absorber surfaces in order to capture heat. So that is how the trapping takes place. So when you talk about maybe the greenhouse effect, the greenhouse effect usually uses the property of light and energy to accumulate heat from the solar energy, whereby the radiant energy, you will find that the radiant energy can pass through a glass or a clear plastic material or any surface that is transparent. Then the radiant energy will pass through it. But the infrared, which is responsible for the heat, the infrared heat radiant, cannot pass through. So therefore, the solar radiation will pass through a glass window of a sealed box, and it is absorbed by the surface behind the glass and radiated. After that, it is radiated. It is radiated, and when it is radiated as heat, which goes through the black surface. So what happens is, what we'll have is that So can put it as an angle there. So we are talking about the energy coming there. Then the surface of this is painted black. Then the radiant energy will get through to this. So here is a clear or a glass material. So it will allow the solar energy through. Then it will not, because it is painted black, it will absorb the heat. And then after absorbing the heat, then this particular place will now have a higher temperature. So in that case, we'll have the heat which will be trapped inside there in terms of what we refer to as the infrared. So the infrared will be trapped, and that particular infrared heat that is trapped inside the solar collector will cause the temperature to rise inside the box. And this one can be used by applications like the solar box cookers, the solar dryers, the solar stills, the solar heated homes. All this can use what we refer to as the greenhouse effect. So maybe if you want, maybe we can look at the diagram of the greenhouse effect. So the greenhouse effect is now what we have here, whereby the radiation is emitted as heat which cannot escape. So the first thing that happens is that the solar radiation passes through the glass. It passes through the glass. Then after passing through the glass, because the walls are painted black, then the radiation is absorbed on the dark surface. And therefore, the radiation is emitted as heat which cannot escape. And that is what we talk about as the greenhouse effect. So you'll find that in application like we can talk of the flat plate collectors used in solar water heating system. They usually take advantage of both the greenhouse effect and the absorption principles to trap energy for heating air as well as the water. So these collectors are usually consist of large boxes with glass windows in front of airspace and black material absorber plates with a layer of insulation behind. So water heating collectors, you will find that they transfer heat they will always transfer heat from the absorber plate and the absorber plate to water flowing through the pipes attached to the absorber plate. So that is how the solar water heater work, especially with the reference to the plate collector. So when you talk about the plate collector, then this is now what we have for the plate collector. So here we have what we call the plate collector. So the plate collector, in this case, we have the transparent, we have the airspace. So the inside is painted black and there is the insulation. And then that particular insulation will heat the water inside the pipe. The particular black surface will absorb the heat. Then the water will be heated inside those particular pipes. And then the pipe for the inlet water, and there is also the pipe for the outlet water. So that is now how we can talk about the flat plate collector. So this is just another way by which it is the principle where that enables the solar water heating system to be achieved. So I want us now to look at the specific solar thermal technologies in use. So now we can look at the solar thermal technologies. When you talk about the solar thermal technologies, then the first technology that is used that we are going to talk about is what we call the solar crop dryers. First one, we can talk about the solar crop dryers. The solar crop dryers. All along we have been drying crops, and drying crops usually involve removal of moisture from the product in order to prevent mold and also to facilitate storage. And traditional methods of drying usually make use of direct solar as well as the wind. So most of the time we usually put the farm product or whatever we get from the farm direct to the sun, and then from there we put it after some time, then it dries in order to stop it from getting molds and also maybe make it easier for preservation. So how does the solar dryers work? So how solar dryers work. How solar dryers work. So when you talk about solar dryers, then the solar dryers usually heat the air with the collected solar radiation and use it in order to dry crops. So they usually heat the air. So you have the air that will be heated, so the hot air will be able to carry out the drying process of the products. Solar dryers usually consist of two parts, and one of them is the solar radiation that is captured. Solar radiation that is captured and used in order to heat the air. And in that case, it increases its ability in order to hold and carry water vapor and actual drying. Then the other one, that we can talk about. So the other one we can talk about is what we call, we can either use the flat plate, or a flat plate collector, or through a window in the drying chamber. Then the type of dryer that is used is always dependent on the product. So when you talk about the solar dryer, then that is how the drying usually take place. So when you talk about a large solar dryers, then we can talk of the drying chamber. And so when we talk about the drying chamber, then this is now where maybe the hot air is passed through and it removes the moisture. And there are several ways by which this one can be done. So we can look at the types of solar dryers that are in use. One of them is the traditional and improved types of solar dryers. We have the traditional. We have the traditional and improved solar dryers. Traditional and improved solar dryers. We have the traditional and improved solar dryers. So when you talk about the traditional and improved solar dryers, then in this case, the drying products are simply placed on the racks that expose them to sun and wind, to sunlight as well as wind. And these dry crops, they usually put outside temperature and humidity as solar radiation and wind combine in order to dehydrate the crop. So in this case, maybe you can have something whereby you have maybe the solar gets inside there. That place may be transparent. Then this is the chamber where you put your seeds. So the solar radiation gets into that, and then these ones are exposed directly. So this is now the rack. And or some of us, you just put them maybe on something like a 10 or whatever, whereby you have your products. So the products, so they get heat directly from the sun, and because also they are aerated, there is also the aspect of the wind carrying away the moisture. So that is how we can talk about the traditional and improved solar dryers. So what some of the advantages of the traditional and improved solar dryers, we can talk about them. One of them is that they are always cheap and can be made with a local material. You can talk about having it made with a local material, and that one makes it cheaper. Another advantage that we can talk about, there is also a combination of use of both wind energy as well as sun, and in order to carry out drying. So that is, it combines both the wind energy as well as the solar in order to carry out drying. The other one is that it moves the products off the ground and outside the fields, and therefore preventing losses to pests and also weather. So as long as it is off the ground, therefore the weather conditions will not be very, very much in effect that can ensure that the particular produce goes bad. We can also talk about another advantage whereby we can both store and preserve crops. So you remember the likes of the granaries that were used. Maybe it was not exposed to solar, but now the heat that comes within, so that one is efficient to carry out the drying of the produce. Some of the disadvantages that are there is that the products are always exposed to the birds and also the bird attack, and as well as the pests, the insects, the birds, and as well as the pests. The other one is that the UV radiation may damage the product. So those ones are two advantages, the disadvantages of using traditional and improved solar dryers. So we can also talk about the direct solar dryers. Second one, we can talk about the direct solar dryers. Direct solar dryers. So that is the second one. We can talk about direct solar dryers. So when you talk about the direct solar dryers, then these ones are just closed insulated boxes inside which both the solar collection and drying take place. So the solar radiation is collected by the greenhouse effect. Through a transparent cover in the drying chamber, and that contains, and then it contains the trays to hold the drying product. Then the heated air circulates through or above the product and removes the moisture and carries it out through the vents. So that is now what we have. So in that case, the heat goes directly to the product, and whatever moisture that is removed is taken out through the vents. So maybe we can have a cross-sectional area of how the direct solar dryers work. So the direct solar dryers usually work like this. So we have that as warm air is removed through the vent. So warm air removes the moisture, so the solar radiation gets in. So this is the tray or the drying rack of where we have the produce. Then the dry, cool air enters through the vent. Then this is the glass cover. So just like what we talked about in the greenhouse effect. So it will allow the solar radiation to get into the where the products are. Then after allowing the solar radiation to get through to the product, then the drying will take place because the infrared will be trapped inside that particular area, and that one will produce a lot of heat, and that particular heat is what is going to remove the moisture content from the farm produce, and therefore the warm air will leave through that particular vent, and that is how the drying takes place. So what are some of the advantages of having direct solar dryers? So when you talk about the direct solar dryers, one of the advantages is that they usually operate at high temperature. Then they usually operate at high temperature than the natural solar dryers. So one of them is that operate at high temperature, usually operate at high temperature than the traditional solar dryers. Another advantage that we can talk about is that high temperatures that they operate within do not, or rather prevents the attacks from insects as well as the microorganisms. So, with the virtue of operating at high temperature, that one prevents the attack by pests and microorganisms. Another advantage is that it dries the crops quickly than the traditional dryers. So, because it has more heat, therefore it dries the crops quickly than the traditional dryers. So what are some of the disadvantages of this? So these ones were the advantages of direct solar. So those ones are the advantages. So let's look at some of the disadvantages. So what are some of the disadvantages of direct solar dryers? So when you talk about the direct solar dryers, some of the disadvantages that that exposure to direct sunlight may cause the product to be damaged by the sun. So the product is actually in contact with the direct sunlight, and therefore that one can bring about the damage. So product in direct contact with the sunlight, thus exposed to damage, So that is another disadvantage. That is the first disadvantage. Another disadvantage that we can talk about is that the dryer is more expensive than the traditional method. Then it comes now to cost. We can talk of it as a little bit expensive compared to the traditional method. So those are some of the advantages that we can talk about as far as the direct solar dryers are concerned. So now we can go to the third one, the third type of solar dryer, which is now referred to as indirect solar dryer. We can talk of indirect solar dryer. So when you talk about the indirect solar dryer, then this one usually make use of the flat plate collector and a separate drying chamber that usually allow the efficient use of solar energy and more control over the drying process. The solar collector, in this case, usually hits the air and dries. It will usually hit the air and dries by what we refer to as the convection. And this forces the convection forces it through the racks. And these racks is what usually, these are the racks that contain the drying products. So this is where we usually refer to as the drying chamber. And such dryers are best used with high value crops. So you cannot use them with low value crops because of the cost. So they are best used with the high value crops and situations where there is a large volume of the product. And that is now where you have them to be used commercially. So that is now how we can use the indirect solar dryer. So we can look at what the indirect solar dryer is all about. So when you talk about the indirect solar dryer, then we have what we have as this. It is not now directly exposed to the sun, but rather there is there is the collector here, whereby the collector will hit the air. So there we will have the air. We will have the air. So we have the cool air getting in. Then this is now the drying chamber. We have the collector plate. Then we have the solar radiation. Then this is now the air that is going to cool. Because of that solar radiation and also the combination of the collector or the absorber plate, will have some sort of hot air going through that, then taking away the moisture from the produce, and then the heat rises through the chimney, and then now here is where we have the drying chamber. So that is how it works. So what we can see is that it is not directly exposed to the sun, but rather the flat plate collector will hit the air. So it is the hot air that is going to go through the produce and then remove the moisture content from the produce, and that is how the drying takes place. So it has got the advantage in that the air, in that now instead of exposing the produce direct to the plant, then we now don't expose the produce indirectly direct to the plant, and now we expose it, we heat the air, and it is the air that will now remove the moisture content from the produce, and that one makes it to be superior to what we refer to as the direct, whereby the products were exposed to the sun directly. So what are some of the advantages of indirect solar dryer? Advantages. So what are some of the advantages of indirect solar dryer? So when you talk about the indirect solar dryer, one of the advantages that we can talk about is that the air that is passing through the collector is preheated, unlike the direct solar dryer. So the air is preheated. Air is preheated. The air that passes through the product or passes through the collector is preheated, unlike the direct solar dryers. The other advantage that we can talk about is that products usually dry much faster. It is faster. The products dry much faster. Then again, the drying products are also protected from direct solar radiation. So drying products protected from direct solar radiation. They are protected from direct solar radiation. They are protected from direct solar radiation. So those are some of the advantages that we can talk about. What are some of the disadvantages? Disadvantages that we can talk about as far as this is concerned. The first disadvantage that we can talk about is the cost. So we can say that it is expensive. And again, another disadvantage that we can talk about is that the construction usually requires special scales. So its construction of the indirect solar dryers, construction require special scales. So those are some of the disadvantages that we can talk about as far as the indirect solar dryers are concerned. So that one brings us to the end of the discussion as far as the solar dryers are concerned. Now we are going to look at what we refer to as the solar water heaters.